So how to calculate probability down here at the bottom. This is going to be pretty simple. In the past, I usually had people leave their probability answers as fractions. We're going to just do the division on a calculator and turn it into a decimal, but it all means the same thing. So probability is the likelihood of an event occurring. Like today, the likelihood that it's going to rain, we would say is 1, because that's 100%, right? We already know it rained anyway. Okay, so probability, it says to find the probability of an event happening, we use the formula, and then it's right here. So probability is the number of desired outcomes over the total number of possible outcomes. Okay, so probabilities range from 0 to 1, so they can be written as fractions or decimals. If something has a probability of 0, then it's impossible. And if it has a probability of 1, then it's 100% certain that it's going to happen. We use the notation, so we use this capital P for probability, and then in parentheses, whatever the probability is that we're looking for, that's what we would put in parentheses. So whatever event we're referring to represents the probability of an event happening. Okay, go ahead and turn the page. All right, so we have a sample space right here for rolling a die, and it says the probability of rolling a number 6. Okay, well, how many 6s are there on a die? How many 6s? Just a 1, so that's where this top number came from. And then how many possible numbers are there? 6. So our probability, so write this down, the probability of rolling the number 6 on a die would be 1/6, and then with your calculators, I would like you guys to go ahead and do that division for me. So just type in 1 divided by 6, and we are going to round to the nearest thousandth. So we're going to carry this out 3 digits. What is it? Point? Okay, so that fourth 6 would make, or sorry, the third 6 would make this one a 7, right? I guess, yeah. Third 6 would make the second 6 a 7. So it is 0.167. That would mean there's a 16.7% chance of it happening. But we're going to write it in decimal form, okay? So once you guys have your fraction set up, just type it in as a division problem on the calculator. That's all you have to do. All right, down here, we've got, here are all the different options of your socks. So the first question is, what is the probability of pulling a white sock out of a drawer? It says out of a drawer. That is supposed to say drawer. That has 30 socks. Well, how many of them are white? You can look down at your paper. There are 12. Okay, so do this. We start with 12 out of 30, and then just go ahead and type that into your calculator for me. Type in 12 divided by 30. Just 0.4? So you don't have to do any rounding there because it's only 1 digit after the decimal. So 0.4 would be our answer. What is the probability of pulling out a red sock? Sorry, I'm writing this down because we really should be writing that. The probability of pulling a red sock, you guys said 8 out of 30? So we start with 8 out of 30, type it into your calculator. So is 0.26 repeating? Is that right? So 0.267. Good. Okay, then the last one. What is the probability of pulling out a yellow sock? 10 out of 30? .3 repeating. Yeah, you guys can put like 0.333 if you want. If it's a repeating, I usually just stick that line over it. Okay, go ahead and turn the page. You guys okay with those? Those are real basic types of probability problems where you're just figuring out the probability of one thing happening. Okay? All right, now, this is where things get a little trickier, is when we are dealing with independent events versus dependent events. Okay, so basically, we're going to have two events occurring, and it says, like, if they're independent, whatever happens with the first choice does not affect what happens the second time around. Okay? If they're dependent on each other, that means that the first choice will affect the outcome of the second choice. Okay, so it says the outcome of one event does not affect the outcome of the other. So if they're independent, it will not affect the outcome of the other. If they're dependent, then the outcome of one will affect the other. Okay? Notice how it says if A and B are independent, then the probability of both occurring is, look at what they did. They took the probability of the first one and they just multiplied it by the probability of the second one. So we're doing multiplication problems here. We're going to take two fractions and multiply them together. Okay? Now, if the second one is dependent on the first, you're still going to multiply the two probabilities together, but the second one you're really going to have to pay attention to. Like, remember the one, for all of you that completed the first assignment, that last problem, the one with the 5 tickets. Each ticket after the first one depended on what happened the first time around. So like we had to decrease the number every time because we didn't put the ticket back in the bag. So the second one, whatever happened with the first affected what happened with the second. So that would be something considered like a dependent event. Okay? So down here at the bottom, it says a box contains 5 red marbles, 3 blue marbles, and 7 white marbles. Okay, so the question, all they want to know is this independent or dependent? So, if they want us to find the probability of picking a red marble, then a blue, the first marble is selected, and then the second one is selected without replacing the first. So they've taken, let's say we reach in, we pick a marble. How many were there to start with? 15 total marbles?
Yeah.
So let's just say we reach in, we pick one. There were 15 total to choose from. If we don't replace the first one, are there still 15? There's 14. So doesn't that first choice affect what happens with my second one? So that means they're what? If it affects it, it's dependent. So that's a dependent type of probability problem. Now, if the first marble is selected and then they put it back in, is it dependent or independent?
Independent.
It's independent. So anytime they replace it, it's independent because you still have 15 in there. But if they don't replace it, then every time it's not replaced, the total number of outcomes decreases by 1. Okay? All right, go ahead and turn the page. All right. A coin is tossed and a single die is rolled. Okay, so will that coin affect the die? No, because they're two different things anyway. Okay, so we want to find the probability. So the probability of landing on heads and then rolling a 3. Okay, so this is our probability. So let's start with the fraction we would use for the coin. How many total options are there on a coin? The total goes on the bottom. and heads would just be 1 out of the 2, right? So the probability of getting heads is 1/2. Now let's talk about the die. How many options are there on a die? 6. And we just want the number 3. Isn't that 1 out of 6? Okay, so that's 1 out of 6. So this probability here is for the coin, and this probability here is for the die. We're just going to multiply them together. Now you guys can do that on the calculator, or you can just go ahead and multiply straight across, like 1 times 1 is 1, 2 times 6 is 12, and then you guys can do that division. If you don't want to do it that way, do you guys know how to type this in? You would do like 1 divided by 2 times 1 divided by 6. And then you guys tell me what you're getting. 0.083?
Yes.
And the 3 repeats? Yep. I like the independent problems better. They're just easier because you don't really have to think about that second one, because the first one didn't affect what happened with the second one. When they become dependent, that's when things get a little trickier. Okay, so the one down here at the bottom, it says an experiment consists of spinning a spinner 3 times. For each spin, all outcomes are equally likely. What is the probability of spinning a 5 all 3 times? Okay, so the probability of getting a 5, a 5, and a 5. Well, the first time you spin it, what's the probability of getting a 5? 1/5. How about the second time? 1/5. And how about the third time? 1/5.
3 times the charm.
So all you guys have to do is now multiply and divide. So I know it's 1 over 125. I always multiply out my fractions first, and then I would do the division. Or you can just type it in, 1 divided by 5, 1 divided by 5, 1 divided by 5. Whatever. What are you guys getting? Point?
0.008.
0.008. Yep. Okay. How do you guys feel about independent? Is that fine, what we've been doing? Okay, because now we're going to switch to dependent. All right, Miss Winner needs 2 students to help her with a science demonstration for her, I don't know what that is, class of 18 girls and 12 boys. Okay, so she randomly chooses 1 student who comes to the front of the room. She then chooses a second student from those that are still seated. What is the probability that both students chosen are girls? Okay, so let's think about this. First of all, how many total students are there? Okay, there's a total of 30 students to start with. So first student she picks is a girl. How many girls were there out of 30?
18.
Okay, so the first probability is pretty straightforward. However, that person is going to stay up here. So do we still have 30 people to choose from? No, we're down to how many the second time? We're down to 29. Now, if they said the second one was a boy, aren't there still 12 boys? Okay, but it doesn't say a boy, it says a girl. Are there still 18 girls? No, because one of those girls is up front. So instead of 18, it's 17. So you have to be really careful with the dependent ones, because it's not always going to be straightforward. Like sometimes that denominator is going to decrease by 1. Now you guys have to do the math there. I'm relying on you to do this multiplication. I guess I could do it on my calculator, but I'd rather you guys do it anyway.
It's a long decimal.
306/8.
Well, so you left yours as a fraction. So now go ahead and do your division now. Like take the top divided by the bottom. So I have, if we're rounding to the nearest thousandth, I have 0.352 because the 7 would make the 1 go up. Okay. 0.352. Is that okay?
And it's only the 7.
All right, then let's try the one down here at the bottom. This is still dependent. It says in a shipment of 20 computers. I'd really like to know where these word problems came from because we're missing an S there. 3 are defective. 3 computers are randomly selected and tested. Okay, so hang on. We know we're picking 3 computers, so this time we're going to have 3 fractions being multiplied together. What is the probability that all 3 are defective if the first and second ones are not replaced? So that's how you know it's dependent, because we're not putting it back. Okay, so if we want the probability of all defective, I'm putting all like D's. Those are capital D's. I don't know if you can tell, but they kind of look like zeros from there, don't they? Well, probability that the first one's defective, the second one's defective, and the third one's defective. Okay, first time we pick a computer, how many total are there? And how many of them were defective? Okay, first one's pretty simple, 3 out of 20. Now we leave that defective computer out, so how many computers are left? And how many of them are still defective?
2.
The first one we picked was defective, remember?
2.
So then 2 of them are defective. So the last pick, are there still 19?
No, 18.
There's 18. And if both of these were defective, there's just 1 left, right?
Yeah.
Okay. There are your 3 fractions. So that time you had to decrease the numerator and the denominator by 1 every single time. Now you're going to have to carry it out more than 3 digits because there's some zeros, right?
Yeah. Do you know how to round up on this?
No, I would just, it's what, 0.000,
8777193.
I would just make it 88.
I'll put 88, yep. Yeah, normally I'm going to tell you guys to just carry it out 3 digits, but like rounding it to 0.001 is a little too much rounding. So if you have that many zeros, carry it out like 2 more digits past it, just because those zeros make it a little too much rounding if we just stop there. I know, right? All right, next one. This is our last page of notes. See, this one's going by quick.
Do you want to put the W in it?
I don't think so. Okay, last one. A bag contains 5 chocolate chip, 3 peanut butter, 4 oatmeal, and 4 sugar cookies. So before we do anything, I need a total number of cookies here. 5, 8, and 8 more. So we have 16 total. You always want to know the total because that's going to be the bottom number to start with. So if Tia randomly selects 2 cookies, what is the probability that they'll both be sugar cookies? Now listen, they didn't say if she replaced it or not, but the fact that they said they want us to do this as dependent means that she didn't replace it. Okay, so the probability of getting a sugar, then a sugar. First time she reaches in, how many out of the 16 are sugar?
2.
4 sugar cookies out of 16. Now the next time, there's no longer 16. There are 15 total cookies, right? Because she didn't replace it. And are there still 4 sugar? No, there's 3 sugar. Mine just is 0.05. It just ends. Well, if it just ends, you guys obviously don't have to carry it out 3 digits.
Mine doesn't just end at 0.5.
It should.
I
Did,
did it wrong.
okay, I was gonna say, you probably typed in a wrong number somewhere.
I put 14 instead of 16.
Okay, yeah. That'll make a difference.
Yeah, very much so.
Okay, then Vanessa randomly chooses 2 cookies. What is the probability that the first will be a chocolate chip and the second will be a sugar cookie? Okay, so the first time Vanessa reaches in, there are 16 cookies total. And how many of them are chocolate chip?
35.
5. Second time she reaches in, she has not replaced the cookie. So are there still 16?
No, 50.
There's,
Did we continue it from the other one?
no. This is something completely different. So there were 16, now there's only 15. And how many of them are sugar cookies?
4.
There's still 4 in there. And then go ahead and do your multiplication. Oops. I got the 0.083 repeating.
I'm glad for the repeating simple.
Okay. Now down here at the bottom, we're just going to talk about whether we think these are independent or dependent events. So we're going to put the letter I if we think it's independent. We're going to put the letter D if we think it's dependent. Okay. Flipping a coin more than once. Independent, right? The first flip isn't going to affect the second flip. So we can just put the letter I. Choosing a shirt and pants from a group of choices. What do you guys think? Will the shirt affect the pant choice? No, they're independent of each other. They're 2 different items, so they're not going to affect each other. Now, if it was choosing a shirt and then choosing another shirt without replacing the first shirt, then it would be dependent, right? Okay, this next one is kind of weird. It says sitting center courtside at a Pacers game. Well, wouldn't that depend on where somebody else is sitting?
Yeah.
So probably dependent, right? It's going to depend on, like, are we necessarily going to be able to sit center? I don't know. It's going to depend on everybody else.
I was thinking of the same thing.
You were what?
I was thinking of the same thing.
Okay. Yeah, because in my mind, I was thinking it depends on where everyone else sits, so that makes it dependent. All right, next one. Drawing a card, replacing it, so we do put it back in, and then drawing another card.
Independent.
That's independent. Independent because we replaced it. If that said without replacing, it would be dependent. Finding a shopping cart at the store. Depends on everybody else, right?
Yeah.
Good job. Finding a seat at a certain table in a classroom.
Dependent.
Dependent. Some of you guys had to move around today because somebody else chose where you normally sit, right? So it depends on where everybody else sits. Spinning a spinner more than once. Well, isn't that just like flipping a coin more than once? It's independent. The first spin isn't going to affect your second spin.
What did it again?
Oh, I'm sorry. I always forget because I'm looking at it, so I forget what's going on up there. Choosing a chocolate out of a box of chocolates.
Dependent.
Dependent, because it's going to depend on what's
You never know
left.
what you're gonna get.
Right. Yeah. Choosing a number 1 through 10 to win a prize.
Dependent.
Dependent.
Well, I mean, I could do the keep the version, which is mom says that all of us chocolate instead of chocolate, and he said chocolate.
All right, so that's the end of the second lesson. It's all about independent versus dependent. I'm going to give you guys your second practice page, and that is the last thing you have to do. Most of you should probably be done by like 2:55 at the very latest.